Hello, I am George Rodriguez, Senior LATAM Business Manager, and today I want to talk to you about the frontier that is changing the way we think about fungicides and biologicals in agriculture, the combination of nanotechnology and essential oils. When we look at plant health, we know that most field diseases have a fungal origin. Estimates cited in the literature suggest that around 70 to 80% of plant diseases are caused by pathogenic fungi, which explains agriculture's historical dependence on highly effective synthetic fungicides. That story has been successful for decades, but it has also brought two important side effects. The first is the rapid development of resistance in several pathogen species. The second is the growing pressure for lower environmental impact, lower toxicity to non-target organisms, and a better residue profile in food. In this context, essential oils have come onto researchers' radar as natural candidates for biofungicides. These oils, extracted from different aromatic plants, are rich in terpenes and other aromatic compounds with a wide range of biological properties. They act on multiple cellular targets, which reduces the risk of resistance and, in many cases, offers a more favorable toxicological profile. However, for those of us who think like formulators, there is a structural problem. Essential oils are by nature poorly soluble in water, volatile and unstable when exposed to light, oxygen and temperature. In other words, they are almost the opposite of what we want in an ingredient that needs to be formulated, stored, diluted in spray tank mixes and applied precisely in the field. This is where nanotechnology appears as a bridge between the biological potential of these oils and the operational reality of agribusiness. The core idea is to encapsulate these compounds in nanometric structures, whether in the form of nanoemulsions, nanoliposomes, nanocapsules or nanofibers, using matrices such as modified starches, proteins or cellulose derivatives. When we bring the essential oil inside this structure, we gain several immediate benefits. First, we increase apparent water solubility, making tank dispersion easier. Second, we protect the active ingredient from degradation by light, oxygen and temperature, improving shelf stability and performance during application. Third, we gain better control over the release of the compound at the target, whether on the plant surface or at the pathogen interface. Projects carried out in research institutions show, for example, the development of nanoformulations based on essential oils aimed at controlling nematodes and soil fungi, where particle size, emulsion stability, refractive index, turbidity, and ultimately biological activity against specific pathogens are measured. In these studies, the expected outcome is precisely to reach stable, scalable formulations with consistent fungicidal or nematicidal effects. From the perspective of those formulating biologicals, a new product category emerges: natural origin biofungicides supported by advanced formulation engineering. This is not simply about replacing a synthetic molecule with a plant extract, it is about building hybrid systems in which nanotechnology compensates for the physical and chemical limitations of essential oils. This opens up a series of strategic pathways. We can think in terms of foliar contact products, seed treatments, soil applications, or fertigation solutions, always assessing which nanometric system makes the most sense, which particle size is ideal, and which biopolymer offers the best combination of stability and biodegradability. At the same time, it is important to recognize the barriers. Nano-encapsulating an essential oil under laboratory conditions is one thing. Scaling up that process with reproducibility, quality control, and competitive cost is another. Ensuring storage stability, compatibility with other molecules in the spray mix, and a clear regulatory pathway requires investment, time, and partnerships. In several countries, the regulatory discussion around nanostructured products is still evolving, especially when natural origin ingredients are combined with artificial structures. This means that companies entering this space early will need to deal with regulatory learning, but they will also be able to influence standards, guidelines, and technical norms. For the AgroLatam Intel audience, the message is direct. If you work in R&D, formulation development, business, or partnerships in the biological sector, it is worth looking at nano-encapsulated essential oils not as an academic curiosity, but as a potential portfolio pillar in the coming years. We are talking about solutions that can combine agronomic performance, a strong ESG narrative, and real differentiation in markets saturated with more of the same. By connecting the knowledge coming from research with the reality of formulators and manufacturers in Latin America, we create bridges to new products, new categories, and new business models. If this topic makes sense for your company and if you see room to incorporate essential oils and nanotechnology into biofungicide projects, seed treatment solutions, or integrated management tools, I invite you to take this conversation further with the AgroLatam Intel team. The next wave of innovation in crop protection will probably not be only about a new molecule, but about how we formulate, deliver, and position that technology in the field. And that is exactly the vision we want to build together with you.